In the final years of World War II, as Japan's empire crumbled and its skies filled with American bombers, engineers faced an impossible order: build planes without metal. What followed was a feat so strange it bordered on madness: wooden aircraft designed to outsmart radar. They were silent, ghost-like, and invisible to the eyes of the enemy. But behind their creation wasn't arrogance, it was desperation. This is the story of the men who tried to turn lumber into lightning. A story not of war, but of the impossible choices that come when a nation has nothing left but its imagination. By 1944, Japan was bleeding from every industrial vein. The skies above Tokyo glowed orange most nights, lit by fires that never seemed to die. American B-29 superfortresses came in waves, their aluminum bodies gleaming in searchlight beams, untouchable at altitudes Japanese fighters could barely reach. On the ground, factories stood gutted and silent. Assembly lines that once hummed with the construction of Zeros and Hayabusas now sat empty, their metal framework skeletal against the smoke-stained sky. The engineers who remained, those not yet conscripted, not yet dead, walked through these ruins with the hollow eyes of men who knew mathematics better than hope. They counted what was left. Barely enough aluminum for 100 aircraft, perhaps 200 if they stripped the fuselages to dangerous thinness. Oil reserves measured in weeks, not months. Steel had become a memory, hoarded by the military for warships that would never sail. In a small office at the Tachikawa Aircraft Company, Chief Engineer Adachi Seizo stood before a blackboard covered in equations that no longer mattered. The numbers told him what he already knew: Japan could not build enough planes to change the war's outcome. They could not build enough planes to defend their own cities. They could barely build planes at all. And yet the orders kept coming. Build fighters, build bombers, build anything that flies. When you can't build from strength, you build from scarcity. When metal fails you, you turn to what remains. In this case, what remained was wood. Cedar, pine, cypress, birch. The forests still stood, after all. The mountains had not yet burned. What if planes made of wood could fool the eyes of radar? The room fell silent. Outside, the distant thunder of bombs rolled across the city like a tide that would not recede. The impossible challenge. The engineers at Nakajima and Tachikawa had spent their careers mastering aluminum and steel, understanding stress points and tensile strength, calculating the precise thickness of metal skin needed to keep a pilot alive at 400 miles per hour. Now they stood in workshops that smelled of sawdust and lacquer, surrounded by carpenters who knew nothing about aerodynamics, but everything about grain and joint and curve. They were no longer building war machines, they were crafting them. The directive had been explicit and absurd in equal measure: construct fighter aircraft without aluminum, without steel where it could be avoided, use wood, bamboo, fabric, glue, whatever could be found, salvaged, or grown. And do it quickly. The war would not wait for them to learn carpentry. At first, it seemed like a death sentence for anyone who would fly such planes. Wood was heavier than aluminum. Wood warped in moisture, rotted in rain, splintered under stress. Wood was what you made training gliders from, not combat fighters meant to intercept bombers at 20,000 feet. But then came the revelation, stumbled upon almost by accident in a research facility outside Yokohama. Radar, the invisible eye of modern warfare. Allied ships and ground stations had been using it to track Japanese aircraft with devastating accuracy, guiding fighters and anti-aircraft fire with precision that seemed almost supernatural. Radar worked by sending out radio waves that bounced off metal objects and returned to the receiver, painting a picture of the sky in electronic signals. Metal reflected those waves like mirrors reflected light. Aluminum was particularly good at it. The very property that made it perfect for aircraft also made those aircraft perfectly visible. But wood was different. Wood absorbed radar waves. Its organic fibers, its uneven density, its lack of continuous metallic surface. All of it meant that radio waves that struck a wooden aircraft simply disappeared into it. Their energy dissipated as heat, their echoes too weak to return to the receiver. A wooden aircraft, properly constructed, could fly through radar coverage and barely register. It would be a ghost in the machine, a hole in the electronic sky. Dr. Tanaka Hideo, the physicist who first calculated this possibility, described the moment he realized it as discovering we'd been given a key to a door we didn't know existed. The Allies and British had built their detection networks assuming all aircraft were metal. They had designed their war around this assumption, and that assumption was a vulnerability. The first prototype was based on the K-84 Hayate, one of Japan's most successful fighters. Fast, maneuverable, deadly in the right hands. The engineers called their wooden version the K-106. They rebuilt it piece by piece, replacing metal with laminated wood, substituting fabric for aluminum skin in non-critical areas, using steel only where it absolutely necessary in the engine mounts and landing gear. The workshops transformed. The sharp scent of machine oil gave way to pine resin. The scream of metal lathes was replaced by the whisper of hand planes, shaving wood into aerodynamic curves. They told us wood was weakness, one engineer wrote in his diary, but in our hands, it became a weapon. The first test flight came on a cool morning in October 1944. The K-106 rolled down the runway, its engine rattling in a wooden frame that flexed in ways metal never did. Observers held their breath. Wood might absorb radar, but could it withstand the violence of flight? The plane lifted. It climbed. It turned and dove and pulled forces that should have torn the wings from their roots. And it held together. More than that, it flew beautifully. The wooden structure, lighter than expected, made it more responsive than its metal predecessor. Pilots reported it felt alive in their hands, organic, as if the plane were an extension of their own bodies rather than a machine they controlled. For a brief, impossible moment, it felt like a miracle, like they had found a way to turn scarcity into advantage, to transform defeat into innovation. The engineers worked through the night, designing more models, refining techniques, dreaming of squadrons of ghost planes that could slip past enemy defenses unseen. They built faster. The orders multiplied. Plans expanded to include not just fighters, but bombers, reconnaissance planes, even experimental jets. If wood could fly, wood could do anything. In those weeks, exhausted and exhilarated, surviving on rice and hope and the momentum of creation, they forgot for a moment that innovation born of desperation is still desperation. That genius under siege is still under siege. The skies above them continued to burn. The ghost machines. The wooden aircraft emerged from Japan's workshops like phantoms taking form, each one a testament to what human creativity could achieve when every conventional option had been exhausted. The Tachikawa Ki-106 became the prototype, the proof of concept, but it was only the beginning. Engineers across the country began experimenting with wood construction, each solving the same impossible problem in slightly different ways. At Yokosuka Naval Arsenal, designers created the MXY-7 Ohka, the cherry blossom. Officially a piloted bomb, though no one used that clinical term. It was a rocket-propelled glider with a wooden airframe and a ton of explosives in the nose. Carried beneath a bomber and released near the target, It could accelerate to nearly 600 miles per hour in its final dive, too fast for interceptors, too small and wooden for radar to track effectively. The pilots called it Ohka. The Americans would call it baka, fool. The irony was not lost on anyone. Here was stealth technology, radar evasion, speed that bordered on supersonic, all wrapped around a weapon that required the pilot's death to function. The greatest innovation of Japanese aeronautics had become a method of suicide. Engineers worked on other projects too, ones meant for survival rather than sacrifice. The Kayaba Katsuodori, an experimental wooden jet fighter that never progressed beyond drawings and a partial mock-up. The Nakajima Ki-115 Tsurugi, a cheap wooden fighter designed for mass production, meant to be built by unskilled workers and flown on one-way missions. Even the famous Mitsubishi J-8M, Japan's copy of the German Me-163 rocket interceptor, incorporated wooden components to save metal. The technical achievement was remarkable. Engineers had discovered that certain lamination techniques, layers of wood glued with synthetic resins under pressure, created structures stronger than equivalent metal in some applications. They found that fabric skin treated with lacquer could be nearly as durable as aluminum while weighing half as much. They learned to shape plywood into curves that aluminum required expensive dies and presses to form. Most importantly, they had solved the radar problem. Tests showed that wooden aircraft produced radar returns only a fraction of what equivalent metal planes generated. At certain angles and frequencies, they barely registered at all. It was genuine stealth technology, discovered and implemented years before the word stealth would enter military vocabulary. They discovered stealth before the world even knew the word. In another time, another context, this would have been pure innovation. In the Cold War laboratories of the 1970s, engineers would spend billions trying to reduce radar cross-sections by fractions of a percent. They would paint aircraft with radar-absorbent materials, design angular surfaces to deflect radio waves, experiment with composite materials, all chasing the same goal these desperate Japanese engineers had stumbled into by necessity. But in 1945, innovation existed inside a nightmare. Every wooden plane built represented not just technical cleverness, but material absence. Every victory of ingenuity was simultaneously an admission of industrial collapse. The engineers knew this. They felt it in every meter of fabric they stretched over wooden frames, in every calculation that substituted available materials for optimal ones, in every design compromise made not for performance, but for survival. Sitting in a wooden cockpit was a sensory experience unlike flying any metal aircraft. The frame creaked and flexed around you, alive in a way aluminum never was. You could feel the plane breathing with the wind, adjusting to turbulence with organic flexibility. The wood smelled of forest and resin even after months of service. In flight, the rattling was different. Not the mechanical vibration of metal, but something deeper, like being inside a living structure that hummed with your own heartbeat. Some pilots loved it. Others found it unsettling, this plane that felt more like riding an animal than operating a machine. And all the while, in the same skies where these wooden ghosts learned to fly, the B-29s continued their work. They came at night mostly, flying above the ceiling of Japanese fighters, dropping incendiaries that turned cities into furnaces. Tokyo, Osaka, Nagoya, Kobe, each burned in turn. The wooden planes, when they managed to intercept, fought with the fury of men defending ashes. The Americans called them woodpeckers when they learned about them, not because of any sound they made, but because the name seemed to capture something essentially feudal about the idea. Wood against steel, craftsmanship against industrial might, an empire running on trees while its enemy ran on oil and aluminum and the entire productive capacity of a continent untouched by war. But the Japanese engineers weren't trying to win anymore. They knew the mathematics. They understood what was coming. They were doing what humans do when facing the inevitable. They were creating anyway, building anyway, finding small problems they could solve even as the larger problem consumed everything around them. In the ghost machines, there was genius. In the genius, there was a tragedy. And in the tragedy, there was something that would outlast the war itself. Proof that even in ruin, the human mind refuses to surrender its imagination. The fall of the dream. The end came not all at once, but in a cascade of small extinctions, each one reducing what little remained. March 1945, American bombers targeted the Nakajima plants directly. The factories that produced engines, the few remaining sources of aluminum, the technical centers where prototypes were tested, all systematically destroyed. Fire consumed buildings filled with wood, and the irony was not lost on anyone. What made the planes invisible to radar made the factories catastrophically flammable. Engineers arrived at work to find their workshops erased. Months of prototypes, thousands of hours of careful craftsmanship, gone in single nights. The smell of burning wood hung over the cities like a permanent fog. April 1945. Material shortages became total. Even wood, abundant as it seemed, became difficult to acquire in the right grades and quantities. The forests nearest the factories had been harvested. Transportation networks lay in ruins. Glue supplies dwindled. Fabric became impossible to find. Some aircraft were completed with paper skin. Paper, stretched over wooden frames, painted with whatever waterproofing could be improvised. They were building planes that could barely survive rain, let alone combat. May 1945. The Ohka missions began in earnest. Cherry blossom gliders released from their mother bombers, accelerating toward enemy ships with pilots who had written their final letters that morning. The wooden airframes held together through dives that generated forces no human body was meant to endure. The radar-absorbent properties worked as designed. American fighters often didn't see them coming until too late. But working as designed meant dying. Every successful Ohka mission was a pilot who would never land, never debrief, never pass his knowledge to others. Innovation consumed its creators. The engineers who had designed these planes sat in their workshops and listened to the radio reports. Each success felt like failure. Each failure felt like murder. They had built wings for men who would never land. Some protested. Some refused to work on modifications that made the suicide craft more effective. Others doubled their efforts, reasoning that if death was inevitable, at least it should not be wasted. The workshops split along invisible lines of those who still believed in purpose and those who no longer knew what purpose meant. June 1945. The order came to destroy everything. With Allied invasion expected, with the possibility of capture becoming certainty, the military demanded that all advanced technology be eliminated. No prototypes could fall into enemy hands. No designs could be preserved. Nothing could survive to be studied. Engineers burned their own work. They dismantled aircraft piece by piece, separating wood from metal so the metal could be salvaged for other desperate uses. They fed blueprints into furnaces, watching months of calculations curl and blacken and turn to ash. Some wept. Others worked mechanically, their faces blank, as if they had already accepted this outcome years ago. One engineer, Yamamoto Kenji, wrote in his journal, "We learned to make ghosts, and then we became them." In a Tachikawa workshop, Chief Engineer Adachi Seizo stood among the burning wreckage of the wooden planes he had pioneered. The heat was intense enough to feel on his face from 20 meters away. Wood burned so completely, so thoroughly, it left almost nothing behind. Not like metal, which melted and could be reformed. Wood became smoke and memory. He had known this moment was coming, had perhaps known it since the beginning, since that first impossible order to build fighters without metal. You do not innovate from desperation and expect triumph. You innovate because the alternative is surrendering your humanity entirely, admitting that when pushed to the edge, you have nothing left inside you capable of response. The wooden planes had been a response, an answer to a question that should never have been asked, and now they were smoke. August 1945. Hiroshima. Nagasaki. Words that meant the end of discussions, the end of calculations, the end of anything that came before. Japan surrendered. The war ended, not with a negotiation, but with 2 flashes of light that made every previous weapon obsolete, every previous strategy meaningless. The wooden aircraft projects were officially terminated. The few planes that survived the burnings were ordered to be pushed into harbors, buried in fields, left to rot in hidden warehouses. The engineers were sent home to cities that no longer existed, to families that had been scattered by fire, to futures that felt like walking through empty rooms in a house you didn't recognize. In the silence after surrender, some of those engineers tried to make sense of what they had done. They had solved real problems. They had discovered principles of radar evasion that were genuine technological advances. They had created aircraft that flew and fought and sometimes succeeded at the impossible tasks assigned to them. But every success had been in service of prolonging a war that was already lost. Every innovation had bought Japan nothing but more time to burn. The wooden planes could outsmart radar, but they could not outsmart history. They could disappear from electronic screens, but they could not make the bombs stop falling, or the empire stop collapsing, or the death stop spreading. In the end, the ghost machines had been exactly that. Ghosts. Beautiful, ephemeral, haunting in their cleverness and their futility. They had existed in the space between what was possible and what was necessary, and they had proven that sometimes those 2 things have nothing to do with each other. The wood burned. The plans burned. The men who built them scattered into a defeated nation, trying to remember how to be something other than at war. And for decades, almost no one remembered that any of it had ever happened. Echoes in the sky. The Americans found what remained by accident. In the months after the surrender, occupation forces cataloged Japan's military technology with methodical thoroughness. They examined radar systems, studied jet engine designs, inspected the ruins of factories and research facilities. Most of what they found was derivative or obsolete. Japanese copies of German innovations, weapon systems that couldn't match American equivalents, the scattered remains of an industrial base that had been overwhelmed years before it finally collapsed. But in a warehouse outside Yokosuka, engineers found pieces of something unusual. Wooden aircraft components, carefully preserved. Fragments of the Ohka glider, parts of the Ki-106, technical drawings that had somehow survived the burning. The initial assumption was that these were training gliders or mock-ups. Wood was not a serious material for combat aircraft. Everyone knew that. Then someone ran the radar tests. The wooden fragments absorbed radio waves at rates that shouldn't have been possible with any material they knew. At certain angles, the radar return was effectively 0. It was as if the pieces were invisible, transparent to electromagnetic radiation in ways that defied the basic assumptions of how radar detection worked. Engineers from Wright Field were called in. The pieces were shipped to the United States for analysis. In laboratories in Ohio and California, American scientists examined Japanese woodworking techniques from 1945 and realized they were looking at stealth technology, not primitive attempts at stealth, not theoretical proposals, actual, functional, flight-tested radar evasion implemented years before the word stealth existed in military vocabulary. The reports were quietly filed. Some of the techniques were incorporated into Cold War research projects. The principles of how organic materials could absorb radar waves influenced the development of radar-absorbent coatings. The idea that you could make an aircraft harder to detect not by speed or altitude, but by manipulating its electromagnetic signature, that concept, stumbled upon by desperate Japanese engineers trying to build planes from trees, became one of the fundamental principles of modern air combat. In the 1970s, when Lockheed began developing what would become the F-117 Nighthawk, the first operational stealth aircraft, some of the engineers involved knew about the Japanese wooden planes. They knew because the technical reports were still in the archives, still available to anyone who knew where to look. The F-117 used angular faceted surfaces and radar-absorbent materials, not wood, but the goal was identical. Make the plane disappear from radar screens. Make it a ghost in the machine. In Japan itself, the story of the wooden aircraft remained largely forgotten for decades. The men who built them rarely spoke about their work. Some felt shame at having participated in a losing war. Others felt grief at the purposes their innovations had served. A few kept private records, journals and sketches hidden in attics, evidence of what they had accomplished that felt too painful to share and too significant to destroy. In the 1990s, Japanese historians began researching the wooden aircraft programs more seriously. They interviewed the surviving engineers, now elderly men with fading memories, but still sharp technical minds. They excavated crash sites, finding fragments of wooden airframes preserved in mud and clay. They pieced together a story that had almost disappeared entirely. What they found was a paradox. The wooden aircraft represented both the height of Japanese engineering ingenuity and the depth of Japan's wartime desperation. They were brilliant solutions to real problems, and they were symptoms of industrial collapse. They were technologically advanced, and they were materially primitive. They worked, and they failed. They were what happens when creativity meets catastrophe. Today, a few examples survive in museums. Pieces of the Ki-106 in the Smithsonian, fragments of an Ohka at the Imperial War Museum in London. A partially restored wooden fighter in a small museum outside Tokyo, its plywood skin carefully preserved, its wooden frame still smelling faintly of the forest it came from 80 years ago. Modern stealth aircraft, the F-22, the F-35, the B-2 Spirit, inherit something from those desperate innovations, not directly, not obviously, but in the fundamental understanding that visibility is not inevitable, that an aircraft can be designed to disappear, that the electromagnetic spectrum is a battlefield as important as the sky itself. In every radar shadow, there's a whisper of those who first tried to disappear. The engineers who built the wooden planes did not live to see stealth technology become commonplace. Most died in the post-war decades, their contributions unrecognized, their names forgotten even in their own country. They did not receive medals or honors. Their work was not celebrated as innovation because it was too entangled with a war their nation had lost and was trying to forget. But they had done something remarkable anyway. In the worst possible circumstances, with almost nothing to work with, they had discovered a principle that would reshape aerial warfare for the next century. They had turned scarcity into advantage, transformed limitation into innovation, found a way to make the impossible fly. They built planes not from steel, but from courage, not to conquer, but to survive. In the ruins of war, they found a truth that still guides the sky. that the line between genius and madness is as thin as a wing of wood, and sometimes the most revolutionary ideas come not from abundance, but from having nothing left to lose except imagination itself. The wooden shavings fall through sunlight, spiraling down in the workshop, catching the light as they drift toward the floor. They fall the way they've always fallen, the way they fell in 1945 when engineers shaped pine and cypress into airframes, the way they fall now in museums when restorers carefully preserve what remains. They fall like snow, like ash, like memory trying to find a place to land. And somewhere in that descent, in that slow spiral through light and shadow, there is still the ghost of a plane that could outsmart radar but not history, that could disappear from screens but not from the sky, that could fly invisible but could not escape the fire that consumed everything it was built to defend. The shavings fall. The story remains. And in the silence that follows, we remember.